Mathematical Practice 4. Model with Mathematics. The standards for mathematical practice, often called the mathematical practices or the math practices, can be found on pages 48 through 50 of the College and Career Readiness Standards for Adult Education. These practices describe behaviors and thought processes that support mathematical thinking and reasoning. So that students have experience with all 8 practices, it's the role of teachers to encourage the practices and incorporate them into activities. This webcast will highlight Mathematical Practice 4, Model with Mathematics. Modeling with mathematics is a way to approach a question that you are trying to answer. The process includes asking a question, identifying and gathering needed information, organizing it into a model through which you can use math to help you, and then evaluating your model based on what you have figured out. So, to begin investigating Mathematical Practice 4, let's start with a scenario outside the math classroom. Perhaps you have been in the situation where you need or want to buy a vehicle. Soon the question comes up, which car should I buy? There is not one right answer to this question. Your decision will depend on the decision-making model that you create. You may prioritize value, safety, and reliability, while someone else in your neighborhood prioritizes cost, miles per gallon, and availability. After you do all of your research, you will be able to use it to decide which car to buy. Are you satisfied with your purchase? Now that you have the car, what are some additional variables that you wish you would have considered? Answering questions like these is all part of modeling. Now that you've got a sense of the meaning of this practice, let's look more deeply into what it means to model with mathematics. I'll highlight 3 features of this mathematical practice as well as example activities at different levels that work with each feature. All of the math content examples that I share can be found in the College and Career Readiness Standards for Adult Education. When you work with Mathematical Practice 4, you'll be guiding your students to ask meaningful questions about the world around them, identify, gather, organize, and work with relevant information, including mathematical information, and evaluate the effectiveness of a model by checking the results in context. To encourage learners to ask meaningful questions about the world around them, given a prompt, image, or scenario, you could ask them, "What do you notice?" and "What do you wonder?" For example, you could show this prompt from one of Dan Meyer's 3-act tasks to both higher and lower level learners. What are some things that your students might notice about this image? What are some things that they may wonder? Students may notice that the routes are part of circles. They may wonder where this is. They may wonder which route is shorter. They may notice that one segment of the circle looks different from the other segments. After generating lists of what they notice and wonder, choose one or more questions to investigate with a model. Even though the prompt is shared, the models may be different based on the skill levels of the learners. By encouraging learners to ask meaningful questions about the world around them, you'll see them being engaged in the learning process regardless of their previous experiences with math. Now let's continue to the second feature of modeling with mathematics. To encourage learners to identify, gather, organize, and work with relevant information, including mathematical information, you could ask them, "What are you trying to find? What else do you need to know? And how can you organize this in a useful way?" To continue with the 3-act example, if you are investigating the question, which route is shorter, a lower level math student may use measurement to answer this question. They could measure with non-standard units by counting the dashes in each of the lines. They may ask for a ruler or tape measure in order to measure and compare the distances. The units that they use would depend on the size of the image, whether it was projected to the group or printed on paper. The level of accuracy would also vary based on skill level, available measuring devices, and perceived need for accuracy in making the comparison. At a higher level, students who know how to work with the relationships among measurements within a circle may want to know actual measurements. In that case, you could share this additional information about the diameter of the circle with them. These higher level students could then perform the calculations needed within the model that they have created, still trying to figure out which route is shorter. By encouraging learners to identify, gather, organize, and work with relevant information, including mathematical information, you'll find that you will see them invested in the problem-solving process, motivated by curiosity rather than just trying to follow given steps. The third feature of modeling with mathematics is evaluating the effectiveness of a model by checking the results in context. To encourage this, you could ask students, was your model effective in answering your question? What worked? What would you change? To evaluate the effectiveness of a model by checking the results in context, you could share the third act of this three-act task. Did your students arrive at the correct answer? Now that they have seen Act 3, is there a way that they would revise their model? Don't let the discussion end when students have seen the answer played out. What other questions could you ask them about the effectiveness of their models? By encouraging learners to evaluate the effectiveness of a model by checking the results in context, you'll see them considering aspects of various solutions and the merits and drawbacks of each. Each of the previous examples illustrates how students could model with mathematics. Now let's watch these adult learners create mathematical models for a more complex scenario.
Good morning, everyone. Thank you so much for coming today, spending your Saturday with us. My name is Brigitte Lahme. I'm the department chair of the Department of Mathematics and Statistics at Sonoma State University, and I also do a lot of professional development with the teachers in our local area. Today, the topic of our workshop is effective use of modeling tasks, and one of the reasons why we picked modeling is because there's a new emphasis on modeling in the Common Core State Standards. And I hope that the teachers, after going through the day today, will be able to really think about, okay, I'm in a unit, this is the content, this is functions, graphing functions, how can I use a modeling problem to teach this? And if they do a geometry problem, if they're in a geometry unit, same thing. A lot of people think about modeling as something that you do after you cover all the skills and all the content, but really, modeling is a great way to teach content. And it's not so much a problem, it's just a statement from a blog that I came across. So it states that solar energy exploitation definitely makes sense in an area that receives 9 kilowatt hours per square meter of solar energy per day. And it definitely doesn't make sense if it only receives 2 kilowatt hours per square meter of solar energy per day. What math questions come up for you when you're seeing that, when you're reading this?
I've never thought about it before, so what does 9 kilowatts in meters squared look like?
Okay, what do these units mean? 9 kilowatt hours per square meter, is that a lot? How much is this? There are many different questions that we could explore. And so how about for today, we're gonna, rather than look at the whole globe, let's pick one small part of the globe, Santa Rosa, and answer the question if it makes sense to exploit solar energy just in Santa Rosa, because that's where we are. One of our goals for today was to explore graphical representations of functions. And so that was the data I wanted the teachers to use when they were working with the problem.
So add it all up.
Multiply it by the number of hours, and that would give us the units that we want. And then we can compare that to the 9 kilowatt hours per meter squared.
At some points it's really low, but other points it's high, so that's why we're kind of looking
15
at
hours.
15 hours. And then we could just choose a number, as I say, 400 is about the average middle. Okay.
They had to get from the data that they had to, figure out, grapple with, I need to take this data that gives me solar radiation in the units I have and turn it into energy in the units quoted in the blog. How do I go from one to the other?
If we can change that into kilowatt hours, then we can find out during that hour what the kilowatt hour is that we are taking in.
Let's say from 4 to 5, right? Where it's going from about 550 to 425, right? So could we say that we're collecting about 500?
Just averaging.
Yeah, that seems reasonable.
Let's just add some stuff up.
Sure.
All right, so let's look at some of the methods that you guys used and the assumptions that you made.
So we found a source on the website where we could just look at the hours, and they gave us the kilowatts per meter squared.
Watts per meter.
Watts per meter. So we just added up the data points, and we just said for that day we got so many kilowatt hours.
So for example, like in August, we took from 7 a.m. to 8 p.m. It was a total of 5,437 watts per meter squared, converted that to kilowatts per meter squared. And then I guess an assumption that we made was that that also would represent kilowatt hours.
How did the teachers in the video demonstrate that they were modeling with mathematics? Did you see them ask meaningful questions about the world around them? Did you see them identify, gather, organize, and work with relevant information, including mathematical information? Did you see them evaluate the effectiveness of a model by checking the results in context? All three aspects may or may not have been demonstrated in this particular video. What other mathematical practices did you observe? Feel free to pause the webcast while you think about or discuss these questions. The teachers in the video were asked to ask and answer questions in response to a prompt. This modeling task will give students at all levels an opportunity to practice answering their own questions that involve math. In planning for the lesson, you can decide what additional tables, graphs, maps, images, or other resources would enrich their learning experience. In conclusion, I want to share this poster that summarizes Mathematical Practice 4, Model with Mathematics. The next slide shows the link where you can download the poster to print and post in your class, as well as links to all of the other resources used in this webcast. How will you encourage students to model with mathematics?